All right, welcome to the AI Research Roundup. I'm your host, Alex, and it's May 3rd, 2025. Today, we're diving into this ICLR conference paper, published just over 3 months ago on January 22nd, called Context-Parametric Inversion, Why Instruction Fine-Tuning May Not Actually Improve Context Reliance. So this paper looks at a surprising issue. Instruction fine-tuning can actually make models worse at following context when it conflicts with what they already know. Okay, so this figure really highlights that surprising finding. On the left, we see counterfactual context reliance plotted against standard benchmark performance for several models: Llama, Pythia, Mistral. Notice how reliance initially climbs, but then it drops significantly, even as the models get better on those standard tests. The right side helps explain why, distinguishing between context-critical examples, where the context is essential, and non-context-critical ones, which might reinforce existing knowledge. Building on that, this next figure breaks down the effect across different types of knowledge conflict for the Llama 2 model, fine-tuned on Tulu. We see plots for counterfactual quotes, biographies, and world facts. In each case, the blue line showing accuracy using the provided counterfactual context peaks and then drops, while the orange line, representing reliance on the model's internal knowledge, tends to rise later. This reinforces that inversion pattern consistently. Now, this figure gets into the why. Panel A shows that even filtering for simple fact overlap between the training and test sets doesn't prevent the drop in context reliance. But look at Panel B. When fine-tuning focuses only on context-critical examples, that green line, the reliance stays high. It only drops with the full dataset or context-only data. This strongly points towards the mix of training examples being the culprit here. Okay, so if the training data mix is the issue, can we fix it? Well, this figure explores some potential mitigation strategies. Panels A and B show what happens when you add counterfactual data during fine-tuning for Alpaca and Tulu. It definitely helps boost counterfactual accuracy on similar tasks, see those dotted lines, but it doesn't seem to generalize well across different types. Panel C shows fine-tuning just the query and key matrices. This gives a potential gain but hurts standard benchmark performance. And just to show this isn't limited to one model or dataset, this figure illustrates the same context-parametric inversion effect, but this time with Mistral 7B fine-tuned on UltraChat. Across counterfactual quotes, biographies, and country capitals, we again see the blue line for counterfactual accuracy peak and then decline, while the orange parametric accuracy line often trends upwards later. So this really reinforces the generality of the inversion phenomenon across different setups. Okay, so you might think, well, just tell the model to follow the context, but this figure shows it's not that simple. Here, they compare standard prompting, in blue, with an explicit context-adhering prompt, in red, across the same counterfactual tasks. And look, even explicitly prompting the model, shown by the red lines, doesn't prevent that characteristic drop in context reliance. It still peaks and falls off. So even telling the model directly to follow context doesn't fix this inversion problem we've been discussing. All right, the big takeaway here is that instruction fine-tuning can surprisingly make models less reliant on conflicting context, even as they improve on benchmarks. This seems tied to the mix of training examples. It definitely shows a key challenge for building truly adaptable LLMs. That's our roundup for today. Thanks for joining me.